Hello, everyone. Welcome back from the Shape Center spread videos. We're now going to focus on spread. So range you've seen before, interquartile range you would have seen before. What's new is standard deviation. So definitions, range, difference between the highest and lowest value. Interquartile range, the difference between upper and lower quartile, that's a subtraction. And standard deviation, you've got some information down here about the formulas for standard deviation. When we get to standard deviation, I will explain that a little bit more detail. But one of them is you're calculating it if the data you have is a sample. Another one is you use it if the data that you have is a population. Lowercase n is the sample size. Capital N is the population size. Here you subtract by 1 because if you divide by n, it tends to underestimate the true standard deviation. We'll talk about that a little bit more when we get to it. Okay, so first, let's talk about range. So range, we've got two different data sets, 9 values. The range for this one, highest value minus lowest. Now before we calculate, look how different the two data sets are. This one's pretty evenly spread from 5 to 45. This one, most of your data is from 5 to 12, not very spread out. And you've got the one outlier, 45. But if you use the range to describe the spread of your data, biggest number minus the smallest, you get 40 here. Biggest number minus the smallest, you get 40. And having a range of 40 and 40, you would think that your data sets are similarly spread out, but you can tell that by looking at it. The second data set is not very spread out. It's very close together except for that number. So for that reason, range is not a good descriptor of how spread out your data is. Better version is interquartile range, IQR. All right, so as the formula said, it's going to be upper quartile minus lower quartile. So I'm going to split this into 2 on our screen. We have 2 separate data sets. And here's how we find quartile 1, lower quartile, and quartile 3, upper quartile. First, you find the median, the middle number. 9 numbers. Here's the middle one, right? So your median is 25. So now that's the middle number of your data set. Lower quartile is the middle of your bottom half. So not including the median, everything that's less than the median, I'm going to look at that. And now I want to find the middle of the bottom half. Well, looks like I have 2 middle numbers, 10 and 15. Well, I got to take the average of those two. It's 12.5. So that gives me the lower quartile. And that's 12.5. And now for the upper quartile, remember this was the median. For the upper quartile, you look at all the numbers bigger than the median. Notice that I don't box in the median, just everything bigger than it. I find the middle number, looks like there's 2 of them. I need to average them. That's 37.5. So for my upper quartile, I get 37.5. And so now for my interquartile range, you subtract the upper and the lower quartile. So 37.5 minus 12.5. And that gives me 25. So the IQR for this one is 25, which makes sense. It's fairly spread out. Looking at this one, because it's not as spread out, most of my data values are close together. excluding the outlier, we would expect that if we're talking about a measurement of spread, that the measurement of spread here would be less than the measurement of spread here. That's why range is not a good way to describe it, because we came up with the same thing. So we're going to go through the same process, median, lower, and upper quartile. I'm going to find the middle number. It's 9. 4 numbers above it, 4 numbers below it, puts it in the middle. I'm going to go to my lower half, all the numbers less than the median. 2 middle numbers, I average them. So my median, remember my median here was 9. My lower quartile, 6.5. And from my upper quartile, I look at all the numbers above the median. There's 2 middle numbers. I average them. I get 11.5. And then for IQR, again, I need to subtract lower quartile from upper quartile. So 11.5 minus 6.5, that's a minus sign. And we get 5. Now these two numbers are good descriptors of spread. It tells you here that IQR is 25, the IQR here is only 5, which tells me that the data set this came from is much more spread out than the data set that this one came from. And you can look at it. Most of these numbers are close together, 5 through 12. There's not a lot of spread. We came up with 5 as an IQR. Here, the numbers are very spread out. They're 5 apart from 5 to 45. They're not bunched up, and we get a large IQR of 25. Okay. So whereas range gave the same number, IQR gives us a better measurement of spread. It's a better comparison of two data sets. All right. So now, box plots. You guys have heard them referred to probably as box and whisker plots. All right. We already have 3 of the key numbers that we need. We had the median. This was our second data set, by the way. Our median, 9. When you calculated quartile 1, we averaged these 2. That was the lower quartile, which is also referred to as quartile 1. That's 6.5. And the upper quartile, we looked at the numbers bigger than the median. There were 2 numbers, we averaged them. The upper quartile is also called quartile 3, 11.5. The other 2 numbers that we need for a box plot is the minimum and maximum. That's pretty easy. Smallest number on our list, 5. Our biggest number on our list is 45. So you can see that I've already created a number line. I've counted tick marks from 5 to 13. I did not continue tick marks all the way up to 45. You can imagine the rest of them, and then 45. So the way that I create a box plot is it doesn't matter. You can start with any of these 3. But I'm going to create a vertical line for all 3 of those. I start at the median. Median's at 9. So I create a vertical line at 9. Quartile 1's at 6.5. So I come over here to 6.5. Create a vertical line. Quartile 3, 11.5. So I come to 11.5. Create a vertical line. I close these up to make boxes. Okay, so the lower end of the box is quartile 1. The middle of the box is the median, and the upper end of the box is quartile 3 or upper quartile. Now, basically, this represents the middle 50% of your data. So what we're saying here is 50% of our data falls between 6.5 and 11.5. Each section of a box and whisker plot or box plot represents 25% of our data. So we got to finish the rest of the sections. So the minimum value is 5. So I need to go from the lower quartile, draw a whisker down to 5. Maximum value is 45, so I need to go from this end of the box, quartile 3, all the way up to 45. And you can see, because it's so stretched out, that clearly this thing is either skewed right and or has an outlier. Now, by looking at the box plot, we don't know if we have any numbers that are, I don't know, 20, 23, 35, 37, and so on. Right? It just tells you that from quartile 3 to the maximum value, you have to go from 11.5 to 45. Now, each section of a box plot represents 25% of your data. So from the minimum value to quartile 1, 25% of your data falls there. So that would be considered the 25th percentile. From quartile 1 to the median would also be 25%. That is sometimes referred to as the 50th percentile, middle, 50th percentile. 50% less than it, 50% more than it. And then quartile 3, that would be your next 25% mark. All right, so this section represents 25. So now you have 25%, 25%, 25%. So this is sometimes referred to as your 75th percentile, because 75% of your data is less than it, and only this 25% is more than it. Right? Even though it's stretched out and long, it looks like a lot, it's because it's very spread out. There's still only 25% of your data.